So we've talked about rational or polynomial inequalities. Now we're going to talk about rational inequalities, and the process is very, very similar. Think about a rational inequality. Remember, rational expressions are when you have one polynomial divided by another polynomial, and then you're going to have some inequality symbol. Could be less than, could be greater than, less than or equal to, greater than or equal to, and then you're going to want to set that to 0 again. So when you're finding your boundary points, they come from when the numerator equals 0 and when the denominator equals 0. And just remember, the denominator cannot actually be part of the solution set. I should put that up here. Q of x cannot equal 0. So you use it as a boundary point, but it's always going to be a dotted line for those. Okay? Over here, you could have an equal to part. The numerator could equal 0. But let's see what we have on our example here. So it has to be set to 0, and you notice it's not set to 0. So that's going to be the first thing we've got to do. X plus 1 over x plus 3. I'm going to subtract 2 is greater than or equal to 0. Now to do this, I would need one rational expression. So I've got to make this common denominator, a common denominator, and the common denominator is going to be x plus 3. Okay, so what do I do there? Well, I'm going to have x plus 1 minus 2x minus 6. I'll have to distribute that minus 2 thing, okay? So we've done stuff like that before. And so in the numerator, I'm getting negative x minus 5 over x plus 3 greater than or equal to 0. So I have to think about when does the numerator, when does that equal 0? When does the denominator, when does that equal 0? Well, the denominator, that one's easy, at negative 3. And here I'll put 5 on the other side and divide by a negative 1, and I'm going to get negative 5. Okay, so I'm going to go ahead and see if I can just squeeze it on here. Here's my number line, here's 0, and I've said negative 5 is a boundary point, and, oh, negative 3 is the other boundary point. I was thinking one of them was going to be positive. Okay, now, what about the solid dotted line thing? Well, look at what you have here. This is the expression we're going to use, the inequality we're going to use for our test points and stuff. Can the numerator equal 0? Yeah, and we want to know when it equals 0. And that's right at negative 5. So we're going to actually include the negative 5. That'll be a solid line. But the denominator, when x is negative 3, that can't be 0. So we're not going to include that. So we actually get one solid line and one dotted line. That's kind of different. Okay. So now let's think about the test points. And we're going to be using negative x minus 5 over x plus 3. Is that greater than or equal to 0? Yes or no? So think of a number less than negative 5, maybe negative 6. When we're talking about the opposite of negative 6 minus 5 over negative 6 plus 3, is that greater than or equal to 0? In the numerator, I'm going to have 6 minus 5, which is positive, and in the denominator, I'm going to have a negative. So positive divided by negative, that's negative. And so is that greater than 0? Yeah. Now pick a number between negative 5 and negative 3. You probably want to pick negative 4. The opposite of negative 4 minus 5, that's the tricky part, that opposite sign in there. Negative 4 plus 3 is greater than or equal to 0. In the numerator, I'm going to get a negative 1. And in the denominator, I'm going to get a negative 1. Now, that's positive, right? Negative divided by negative is positive. So yes, that section works. And then what about something greater than negative 3? Let's just pick 0. You're going to have negative 5 over 3. Because I'm putting in 0, right, for x. So think about it here. X's are going to 0. Is that greater than or equal to 0? No, because it's negative. So, okay, so we just get the section in between, right there, between negative 5 and negative 3. Okay, so I'm graphing it. It's off my screen, but I can remember. Here's 0, here's negative 5, here's negative 3. We're including the, oh, shoot, I'm supposed to be graphing it. I'm not doing my little test point thing here. Okay, so I want a square bracket on the -5, but a parenthesis on the -3, and then all the numbers in between. And that's going to be the interval from -5 to -3, parenthesis, square bracket on the -5, parenthesis on the -3. All right, and that is how we do that with the rational expression, rational inequality.